In section 7.4, we're going to look at hypothesis testing for a population proportion. A researcher claims that less than 45% of U.S. adults use passwords that are less secure because complicated ones are too hard to remember. In a random sample of 100 adults, 41% say they use passwords that are less secure for this reason. At the alpha equals 0.05 level of significance, is there enough evidence to support the researcher's claim? So as opposed to section 7.2 and 7.3, when we were trying to do hypothesis testing for a population mean mu, we're doing a hypothesis test for a population proportion p. The claim is that the true proportion is less than 45%, or they're making the claim that p is less than 0.45. That's going to be the alternative hypothesis, which is our claim. The null hypothesis would be that the proportion is greater than or equal to 0.45. They specify that the level of significance alpha, we're going to be running this test at the 0.05 level of significance. For us, whenever we're doing sampling for proportions, we will always have a sufficiently large sample, so we will only ever be doing hypothesis tests for proportions anyway that would involve a z-score. As we've done in the past, we know that we're going to take the p-value approach. So all we need to do is calculate the p-value to compare to our level of significance alpha. That p-value will come from a brand new command, which is also under the test menu. If I go to stat, go over to tests, this test is going to be the one prop z-test. So one proportion, and we're going to be doing a z-test for this. We go ahead and hit enter. The p sub 0 plays very much the same role that the h sub 0 did, or the mu sub 0 did back in our last types of tests in 7.2 and 7.3. This is the proportion that's used in the hypotheses. That's going to be that value 0.45. The next thing we need is the x value, which is the number of individuals that reported having that given property. Well, they didn't actually tell us the x value here. They actually gave us the p hat value. They had a sample of 100 individuals, and 41% of them say that they use passwords for this reason. So we can actually figure out the exact number that said that they use less secure passwords by simply taking 41%, that's 0.41, multiplying it by 100, and of course that would tell us that it was 41 people out of our 100 said that they use passwords that are less secure. Our sample size is 100, and then we need to choose the type of test we're doing. Because it is p less than in the alternative, this is a left tail test, so I need to go down and make sure I select the left tail test by hitting enter. We can now go ahead and hit calculate, and we would get that we do get the z-test score, which is negative 0.804, and our p-value for this one, rounded to 3 places, is going to be 0.211. Now that we have p, we can conclude our hypothesis test. P is greater than the level of significance, so the decision is going to be to fail to reject the null hypothesis. So we fail to reject the null. Because of this, when we do our summary write-up, whenever we fail to reject the null, the sentence begins with, there is insufficient evidence to, and then we go back and check to see which hypothesis was the claim. Because the claim was the alternative hypothesis, we would say that it is to support the claim. So there is insufficient evidence to support the claim. Let's take a look at one more example of proportion hypothesis testing. In example 10, they say that a researcher claims that 51% of U.S. adults believe, incorrectly, that antibiotics are effective against viruses. In a random sample of 2,202 adults, 1,161 of them say that antibiotics are effective against viruses. Let's test the claim at the 0.10 level of significance. They're claiming that the proportion is equal to 51%. So our null hypothesis here is that P equals 0.51, and that's what the claim would be. The complement of that, which is going to be the alternative hypothesis, is that P is not equal to 0.51. Our level of significance alpha was 0.10. And we now have all the information we need to do our one prop z-test. So let's go ahead and do that. Again, this is under the stat menu. Go over to tests. Go down to option 5. One prop z-test, hit enter. The P naught value or the P0 value is the one in the hypotheses. That's the 0.51. In our sample, the number that had the quality that say that they do believe antibiotics are effective, that was 1,161 people out of the sample size N, which is 2,202. And then the last thing we need to do is choose the appropriate tailed test, because the alternative was P is not equal to. This is going to be a two-tailed test, and so we need to select the two-tailed test option here. Go ahead and hit enter. We do calculate, and we get that the z-test score would be 1.619. The proportion, or the probability value P is 0.105. Now that we have P, the calculated P value, we simply compare it to the level of significance alpha, and this time it's awfully close. Nonetheless, 0.105 is still greater than 0.10. So once again, the conclusion would be to fail to reject the null hypothesis. So we will fail to reject the null hypothesis. In terms of our write-up, whenever we fail to reject, the sentence begins with, there is insufficient evidence to, and now we check to see for the second half of the sentence which hypothesis was the claim. Because the claim was the null, it will always be of the form to reject the claim. So there is insufficient evidence to reject the claim.